When we talk about the endocrine organs and the endocrine glands, and we talk about hormones flowing all throughout the body, it's pretty easy to develop this mental image of that process happening pretty haphazardly. And so you kind of imagine hormones just coursing all throughout the body, being fired at will and sent everywhere. But if you think about the effects of the endocrine glands, like in the adrenal glands with the fight or flight hormones, it becomes pretty important that the effects being stimulated by these hormones be well controlled, because our body's pretty sensitive to those effects. And so it turns out that the hormone concentration in our blood at any given time is pretty tightly controlled, and one of the ways that it's controlled is through this idea of metabolism and excretion. And so for every hormone that reaches its receptor, thousands more are swept up and removed by the body. And one of the ways that they're removed is through the liver. And the liver will metabolize extra hormones and turn them into bile, which is ultimately excreted in the digestive system. And another organ is the kidney. And you have two of these, and they're filtering your blood all of the time, and they're removing waste products from the blood through urine. And then some hormones are actually just broken down in the blood, and then the products of that breakdown flow into the liver or the kidneys, and then sometimes you can even sweat these hormones out. But the idea here is that all of the time, for all of the hormones reaching the receptors, a lot are just swept up and removed from the body. And another way that concentrations of hormones in the body are controlled are through feedback loops. And the majority of feedback loops are what we consider to be negative feedback loops. And the idea behind negative feedback loops is that conditions resulting from the hormone action suppress further release of those hormones. And that can be a pretty confusing idea, so I'm gonna draw out an example. So we have the hypothalamus here. I'm gonna draw it in. And I'll write it down. And the hypothalamus releases a hormone, thyroid releasing hormone, so TRH. And it releases it, and it goes down to the pituitary gland, which I'll draw in, and right here. And in response to TRH, the pituitary gland releases thyroid stimulating hormone, or TSH. And TSH goes down to the thyroid glands, which would be about right here. And the thyroid gland releases its hormones, T3 or triiodothyronine, and thyroxine. And these thyroid hormones travel all throughout the body in search of the receptors in order to, let's say, upregulate metabolism. That's one of the major jobs of the thyroid glands. And so here's where the idea becomes pretty cool, because some of the receptors are located on the pituitary gland and the hypothalamus, and as the thyroid hormones reach the pituitary and the hypothalamus, they signal the hypothalamus and pituitary gland to stop making their hormones. And the hypothalamus and pituitary gland see that we have enough thyroid hormones in the blood and that they don't need to make any anymore. And so this is a major way that the thyroid hormone levels in the body are controlled. And you might say, hey, that sounds a little bit redundant. I mean, if the hypothalamus can be turned off by the thyroid hormones and it's upstream from the pituitary gland, why does the pituitary gland even have to have these receptors? But the redundance is really just a reflection of how important feedback control is and how important the concentration of hormones in the body is. And so hopefully what we can see is that the hormone levels in the body aren't haphazard and aren't willy-nilly, and that concentration is important.